This is an overview for all the ASTM tests that can be performed on the UTM test machine. For all the procedures, please locate the ASTM D3574-11 for the test specifications. For the IFD test, this test consists of measuring the force necessary to produce designed indentations in the foam product. The specimen shall consist of the entire product, sample, or suitable portion of it, except that in no case shall the specimen have dimensions less than 380 by 380 by 100 millimeters. Specimens less or different than 100 millimeters in thickness shall have the thickness noted in the test report. You should report the force in newtons required for the 25% and the 65% indentation or other indentations. These values are known as the IFD values. Record the length, width, and thickness of the specimen if non-standard, and their ratio of 65% to 25% IFD values. For the indentation residual gauge length test, cellular foam products have been traditionally checked for indentation force deflection by determining the force required to effect a 25% deflection. In seating, on the other hand, the interest is determining how thick the padding is under the average person. The force deflection is determined by measuring the thickness of the pad under a fixed force of 4.5, 100, and 220 newtons, with a 200 plus 3 or minus 0 millimeter circular indenter foot. The specimen, when possible, must be the completed manufactured product. In case of tapered cushions, the location of the area for measurement is to be agreed upon between the supplier and the purchaser. In the case a finished part is not feasible for the test, a 380 by 380 millimeter specimen of an average thickness are to be cut from the cushion. At the end, the report should include the specimen thickness in millimeters at 4.5 newtons instantaneously and at 100 newtons and 220 newtons after 60 give or take 3 seconds. These figures are known as the IRGL values, respectively. Make sure to report the length, width, and thickness of the specimen. For the tensile test, this method determines the effect of the application of the tensile force to the foam. Measurements are made for the tensile stress, the tensile strength, and the ultimate elongation. The specimen shall be cut from a flat sheet material 12.5 give or take 1.5 millimeters of thickness. The foam rise shall be in the thickness direction unless otherwise agreed upon by the customer and the supplier. The top and bottom surfaces shall be parallel and free of skin. The cut edges shall be perpendicular to the top surface and the free range of the ragged edges. The length of the tabs can be adjusted to fit the machine conditions provided that all other requirements remain constant. In the report, make sure to include the tensile strength in kilopascals, the stress in kilopascals at the predetermined elongation, and the ultimate elongation in percent, and whether benchmarks, grip separation, or extensometers were used to measure the elongation. And lastly, the crosshead speed, if other than 500 millimeters per minute. For the tear resistance test, the method covers determination of tear propagation resistance of foam. The block method, as described, measures the tear resistance under the conditions of this particular test. The 3 test specimens shall be a block shape, free of skin, voids, and densification lines. They shall be cut in a saw from sheet material, ensuring that the sides are parallel and perpendicular to each other. A nominal 40 millimeter cut shall be placed in one side. In the report, report the tear strength in newtons per meter, the orientation of the specimen, and the crosshead speed if other than 500 millimeters per minute. The viscoelastic recovery time test uses its methods to determine the recovery time of slow recovery foam. For the specimen, use the standard IFD specimen I described earlier, and for the report, report the recovery time in seconds.